This video PowerPoint presentation is going to help you get through some of those net ionic equations, hopefully on the lab demo type thing we were doing the other day. So, well, let's go straight to it. You have your color chart on the front page that we did together. If you don't have those, you might want to ask someone to let you look at theirs, and maybe they will be kind enough to let you do that. Part 2 is where we get into the net ionic equations. On part 2, letter A, the reaction, of course, we're using, that's a simple one. The potassium and the chloride are both spectators, and you're just going to balance the charges. Here's the molecular equation. Again, get rid of the spectators, balance the charges, everything will be fine. You are writing, of course, the net ionic equation for this one. For letter B, there's a complex anion involved. You'll recognize that by the square brackets on the FeCN6. Complex ions are, again, supposed to be excluded from the AP curriculum, but they keep showing up on the test, so it would be a good idea to be a little bit familiar with it. Notice that the potassium is a spectator. You take those off. There were 3 of them. That leaves the anion, the ferricyanide, I believe, ion, with a -3 charge. And the product will be the iron 2 ferricyanide, I believe, anion complex with a -1. This one's crazy. So your Fe2 plus your FeCN6 -3 will give you that. Oh, by the way, we are including the colors on your net ionic equations to serve as the observations. I think I said that. Yes, I said that back on part A. So there's letter B. Try that one, see what you come up with. Letter C, the barium and the nitrates are both spectators. Other than that, it should be fairly easy for you. We'll move on. D, there are 2 equations. Sodiums and chlorides are spectators. We're going to add the acid to the product of the first equation. That's the sulfite. It should go away after a while. So remember that HSO3, weak electrolyte, weak acid, stays together in the net ionic equation. You can't get rid of that. On E, the sodium and the chloride are spectators. There was no change when the acid was added, so there's no reaction on the second equation for this one. Part 2, letter F, the sodium, potassium, chlorides chlorides are all spectators for these reactions. First, we turn the yellow chromate ion into the orange dichromate ion, and by adding acid to that, we use H+ for acid, of course. The other product is water, and then on the second, we're adding base, also making water, but we're going from orange to yellow on that one. And if you have trouble with knowing how to do those ions, they should be on the first page. All right, part 3, much more complicated, and it gets into the redox, and we just barely touched on that way back early in the year. So we probably have to do some of this together, but you can do some of it on your own. Let's work here on part A. The sodium and potassium, of course, are spectators. Sodium and potassium almost always spectators. Yeah, we'll go with that. So here's the overall reaction. It's not balanced. We might work on balancing that tomorrow in class. And then you're going to add barium chloride to the products. The chloride is going to be a spectator. So the barium should combine with the sulfate, making barium sulfate, which is a precipitate that didn't dissolve. Okay, we're going to write those equations also. Let's move on. Potassium, sodium, still the spectators. The dichromate is going to turn to blue-black, and you may see a chromium ion thing on the front page that has that blackish color. We'll use that ion in the products instead of the manganese ion. It'll be the chromium ion on this one. The sulfite is going to turn to sulfate. Again, there's probably the addition of the barium to make sure that that works as well. So there's probably another equation for that. Part 3, letter C, we're going to take that chlorine, that Cl2, and part of that is changing to the chloride. You can see that right here in the product. We turn our chlorine to chloride, the sulfite into sulfate, the acid, the water that come when we balance the equation. The other 2 equations involve the products of that. You're going to add the silver nitrate to the products, to half of it. Remember, we split this one into 2 pieces. So the silver with the chloride will make silver chloride, of course. And don't have that in front of me, and probably turning the barium, or turning the sulfate into barium sulfate again. So those will be the other two equations. Again, don't forget to add the colors and precipitates and CC for those that are clear colorless when we're doing this. Again, we'll add the oxidizing and reducing agents at the end. Nitrate and sulfite are part D, and the brown gas is suggesting that the NO2, oops, that's not a -1. Let me fix that. That nitrogen dioxide gas is being produced, and we saw that earlier with the, didn't we put nitric acid and some copper and we made that nice brown gas? So it was an NO2 being made. Alright, see how you get along. We'll do part 4 tomorrow when I get back. So let's see how things go for you. Good luck. You can email me if you have trouble, but you probably won't.